This is what we call a stator. What is
Stator.
stator?
Stator.
Okay.
We have a stator now.
We have a stator there. We have a stator there. There's another stator there. This is what we call a rotor. Okay, rotor. Okay, we have a rotor there. Now on the rotor, in front there we have a fan. Okay, that is a fan. Yeah, it's for cooling the alternator. Okay, there. These are what we call slip rings. Okay, am I slip rings? These are what we call slip rings. Okay, so now apart from the slip rings, on the other parts, which parts do you have? We have the bearings there. There's a bearing there, and there's supposed to be a bearing there. Even that one is a bearing. Okay, this is what we call a rectifier. Okay?
Electrifier.
Rectifier or diode part. This is what we call rectifier or diode part.
Yeah.
So now, even there we have a rectifier. Okay?
That's cut.
Okay, there's another rectifier there. So now, there is what we call brushes. Yeah?
We have a was I was in there.
So now, this is what we call a brush holder.
Which one?
This one is a brush holder. So now, we have four brushes there. Okay? There's one brush there, there's one brush there. So now, these brushes, there's a brush there, there's a brush there. So these brushes, they're the ones which come and rest on the what? On the slip rings. So one brush will be there and one brush will be there. So now the function of these brushes is to excite the what? To excite the rotor. Okay? Yes. Once the rotor is excited, it becomes what? It becomes a magnet. Okay?
So what is to excite?
So excite. Excite people, you know.
Yes.
So now, in our field, it's not good for you know. So now, to excite, you introduce a bit of what current on the rotor, so that it becomes what a magnet. Okay, are we there? Clear? Yes. So now, this is what we call a rotor. Okay, these are slip rings. That is a stator. Okay, and that is a brush holder. Here we have two brushes. Okay, this is what we call a diode pack or rectifier. Okay, the function of this is what? To convert the AC to what? DC. AC to DC. Alternating current to direct current. Okay, because on the vehicle we need what? Direct current. So now the alternator
AC to what?
produces AC.
DC.
Then what does this
The alternator produces what? AC. So now we have to convert that AC to what? To DC. So now on the diode pack, we have hammer brushes. So we have hammer diodes. Okay. On the diode pack, we have what we call diodes. So now these diodes, what they do, we have this alternator we're seeing is a three-phase alternator. Okay, it's a three-phase alternator, so which means it has the three windings there. Okay. Now, if you have a four-phase alternator, which means you have how many windings? Four windings. Six-phase, six windings. Five-phase, five windings. Are we there? So now, these windings are the one which produce our electricity. So now, I said there is what we call electromagnetism in the what? In the alternator. So now, once the rotor is excited, it becomes what? A magnet. As it is rotating, because this side is connected to what? The engine, yeah? Through a pulley. This side. Okay? This is a pulley. So this is connected to the engine through a belt, is it? So as the rotor is rotating, there is magnetism there, mind you. So magnetism will be cutting the what? Will be cutting the what? The wires. So as a result, this will produce what? Electricity, which is the AC. Now this AC is connected to what we call what? Rectifier part, which converts what? AC to what? To DC, then it goes into the vehicle. Are we there? So now you find the other magnets, you find the permanent magnet there. So now if there's a permanent magnet as a rod, which means there's no need to have what? Our siblings. Are we there? There's no need to have what? Brushes. So which means the alternator will have a magnet. Yes, permanent magnet, correct. So this is what we call electromagnet, because it only becomes a magnet when you introduce what? Current. Another magnet. The what's the power? This one becomes the magnet. Now these are what we call macro pose. Yeah? These are what we call pro pose. Pro. Okay? Pro mara. These are what we call pro pose. So these pro pose, they where they are. Not Watama, north, south, north, south, north. So north, south, north, south. So this one becomes what? A magnet. When you excite this. Okay? So now I was saying other alternators you find the permanent magnet. Okay? A magnet will have north and south. Okay? So now which means when that magnetism is rotating, it is cutting through the what? It is cutting the windings of the state. So now magnetism now will induce what? Current into the what? Into the windings. Which is what? Alternating current. Yeah? So now that alternating current you have to pass it through the what? The rectifier. So that these diodes which are there, they will allow current to go in what? One direction. So as a result, it is what? It is rectified to what? To direct current. Are we there? One for nine? Clear? So now, these windings, I said they have one phases. Yeah? So now, if you have three windings, which means it's what? It's a three-phase alternator. But what are four? The four-phase alternator. So now, each phase will be connected with what? With two diodes. Negative and positive. Are we there? So each phase will be connected to negative, positive. So which means the three-phase alternator will have one main one diodes. Each phase is connected to two diodes. One negative, one positive. Okay? Each phase is one positive, one negative diode. So now, if your alternator has three windings, so which means how many diodes? Six, right? So three positive, three negative. Okay. So now, the way the alternator is, the windings are connected, there's what we call delta and star windings. Okay. There's what we call delta and star. Okay. So star windings, the way they are connected, star windings, the way they are connected. Okay. There's one common point there. Then you have one winding there. Okay. Another winding will be there. Another winding will be there. So now, if the alternator is connected like this is what we call what? Star winding. So now, if the windings are connected in like that, this is what we call delta winding. Are we there? This is what we call delta. This is what we call star winding. Okay. So now, these windings now they are connected to what we call rectifier. This is what we call rectifier. Okay, this is what we call rectifier or diode pack. So now the way the diode pack is drawn, okay, when you have a drawing of a diode pack, you have like this, okay? You have three lines like that, okay? Then these will be like this. Okay. Are we there? So now we have one more diode. The symbol for the diode is like this. Okay? Then you have a close there. That's the symbol for the diode there. We are doing HE electric, is it? You know this, eh? That is the what? That's the diode packet. Diode packet will be like this. Are we there? This is the negative and that is the positive. Clear? So now the way they are connected. So which means when one winding makes the current, it will come like that, then come and connect it there. Then another one will come and connect the middle one like that. Then another one will come and connect the bottom one like that. Okay? So this side is positive, this side is negative. So when current is produced by one winding, it will come there, then it will go in that direction, then go to the one, the positive. Another one will make it will come and connect there, then it will go that. Current can't go this side because a diode will only allow current to go out in one direction. One for that. Even that one, when it produces, it will come and join there, then take it that side. So this, which means this side is negative, this side is positive. So all the current now will be going what? One direction, which is what? Direct current. Are we there? That's how the rectifier is what? Current from AC to what? To DC. Okay? Same as when you're using the what? The star winding. Same. It's just the same one. You write this 3, right? So this one, that one there, then you have another one there, then you have another one there, you have another one there, then you have another one there, you have another one there. Okay? So which means we have 3. Right? So this one will be connected to the top one, this one will be connected to the middle one, this one will be connected to the what? Bottom one like that. So this one will be positive, that one will be negative. Okay? So now this is how the windings are connected on the what? On the rectifier. So now which means this winding when it makes current it will take it there, then current can't go this side because there's a diode. So it will go in that direction, so which means it will go at direct. So that's how it is. It's converted from AC to DC. Are we there? So now in your exams, whether theory or practical, there are times where you ask you what? To draw what? Am windings, right? Draw a star winding, draw a theta winding, a delta winding. This drawing 4 marks. That drawing 4 marks. So you should know how to draw it. A star winding and a delta winding. Yes. Now what delta, you should know how to draw a delta winding. Now what star winding, you should know how to draw a star winding. Star winding is this one. It's like a star. Delta is this one. No. Delta winding nyaka vyaka. This is the rectifier. Okay. Just like this. It's not a boy. Just delta winding. Sharp and delta winding. Yes. Yes, delta winding. In this star winding. Okay. That is the rectifier. Are we there? 1.9. So now, when you dismantle the alternator, the measurements you carry out on the alternator is what for ground testing and what? And continuity.
Ground testing and
Ground testing and what?
Continuity.
So now, those are the tests you carry out. There's ground testing, there's continuity, there's what we call diode testing. Clear? Continuity, ground testing, diode testing. Okay. So now, when you look at these, I'm a state, right? I'm a windings. Okay? These are windings. Okay? Super wire, it's a copper wire. Now it's insulated. This is made what? So these windings are insulated. This brown color, this is insulation. Are we there? So now, when you look there, you're seeing it? How many wires are there?
2.
How many wires are there?
3.
There.
3.
3, right? How many wires are there? You have seen it? How many wires are there? So what does it tell you? Yes, I don't think it's very but this star will do.
Star.
This star. So upper, A upper.
Oh, yeah.
You have seen it? So this part is that part. So now when you see the alternator like this, that's why it is what? It's how it is. Now, you have seen this, eh? You got your bank. 1, 2, 3. So on each, there are how many ones? 2, right? So we have 2 there, we have 2 there. Okay? So which means this one is what? Delta. So this part is that part. That part is that part. That part is that part. That's how we identify windings, right? So which means is what?
Delta.
The delta. One common point is what? It's our winding. Are we there? This one is what? This one is star winding because it has one common point there. All the wires are meeting there. So it's there. Are we there? So now, when you look at these windings, about have a common point, so which means there are other parts. You have seen there? You have seen that's the part. There's a kawai there. There's a kawai there. You have seen it? There's another one which was there. And we have another one there. You have seen it? 1, 2, 3. You have seen it? What is it? Apple. You have seen there? There. There. Another one there. You have seen it? So which means these are upper, napa, napa. You have seen it? 2, 2. There. You have seen it? So these parts are that one, and that one. Now, these are going to do what? The rectifier. So the rectifier was supposed to be that. Connected to this. Are we there? So they should one wire coming from there, joining the what? The rectifier. One line from there, joining the rectifier. So the rectifier is part of this. When it is connected, it's supposed to be like this. Are we there? We remove this because of what? Bending, eh? Okay, so when it's supposed to be like that, when it's connected. So which means this is part of this. Okay? Are we there? So now, I was saying, these windings are insulated. Okay? So now, which means when winding starts from there, it will go round, and then it will come out there. Another one from there, round, then up to there. Another one, round, up to there. Clear? So now, you can't know whether the windings are okay or when the winding is cut inside, is it? Unless you do what? You do the tests, right? So now, how do you know whether the winding is cut inside or it's okay? You test what we call continuity, eh? Continuity. So now, continuity, you can't know like this. So you use what we call a multimeter. This is our multimeter. Okay. So this is our multimeter. I said the multimeter was what? Probes, eh? When we are doing the battery, I explained that. So these are what we call probes, eh? This is a negative what? Probe. This is a positive what? Probe, right? So now, this black one will go where? Yeah? Common where? There. So now, we are looking at what? Continuity, eh? So the red one will go where? Eh? What voltage who side you, there, is it? Next, what do you do? What do you do? Next, what do? You on the multimeter. Okay? Then next, what do? You put it what? Where? There. You take it. There, is it? Then you get your probes, then you do like this. What means the multimeter is okay? Are we there? So now we want to test the winding. So we are somewhere there. Is it? Up at the base. It's that point, eh? So you put the black probe there, the red probe there. Is it? So now we identify the windings. Eh? One of them is there. Is it? The other one is what? There. Okay. One winding is there. Is it? Another one is there. So these are the points. That point, it can be that, or it can be that, it can be that. So there's one point there, there's one point there, there's another point there. So now, we want to know if from there, if this winding is continuous up to that point, is it? So that's what we call what? Continuity. Then you get your probe, put it there. Okay. We are at that point, is it? That point is that point, is it? Are we there? The point near upper. So now we have identified the what? These lines. That one. We have 1, 2, and 3. Is it? So now we want to know whether from there up to there, if this line is continuous up to there. That's what we call continuity. Okay? So this I did. Okay? So now we have lines, eh? We have the first line is that one. Second line is where? somewhere there, and the third line is somewhere there. So we want to test up to there. Continuous, eh? We do like this. So which means one line is okay, huh? It's not cut inside, is it? Which means it's continuous. Yes, it's okay there. Is brownish color. Nangu twachita so twabika hapa na dalili. Habize, hii insulated eh? Nangu twabika hapa na dalili. Because this is pali hapa na hapa to double. Now, there and there and there. Okay, so now we start eh? So we are testing whether these lines are okay. So we put the red probe there, then black probe there. So one line is okay. I put it okay. We go to the next one.
It's okay, sir.
It's okay. We go to the next one. So don't summarize everything, right? So there is continuity. Tapai line ipo tukemkati. Are we there?
Yes, sir.
So now that is what we call continuity testing, eh? That's what we call continuity. So now next we want to do ground testing. Okay? Ground testing, we want to find out whether the insulation of the wires is okay. Are we there? Whether the insulation of the wires is what? It's okay. So now, as it is, we can't know unless we test it. So now, how do you test the ground testing? Or how do you do ground testing? You get this probe one, put it there. Okay? Then this one will go to F on the housing because the windings are passing there. Is it? So you do like this. Right? So which means the wires they are not what the insulation is just okay. So there is no what ground.
It's okay.
Yes.
Yeah.
Utakalianisha ama wazi insulation nayo unaweka ile kumeku kule housing. That's what we call ground. It is grounding. Out there. Let's test another one. That winding there, okay? Takuja, that winding there. Nothing, eh? That's winding there. Nothing. So which means, what's your conclusion?
The ground is okay.
What's your conclusion? The statement is what? It's okay. Are we there? So we have done continuity. It's okay. We have done ground testing. It's okay. So which means this stator can work. Ngale kunogani yetu inakwata short circuit. Cut there or it can cut there. Is it? Are we there? The line can cut there. The line can cut there. The line can cut there. So which means when testing you have to get 2 points. That point and that point. Is it? Clear? Then that point and that point. That point and that point. Are we there? So now which means there will be continuity. Natwabika hapa na hapa if ile area. Hapa na hapa if ile area because they are connected. They are interconnected in a triangle form. Is it? So let's start testing, eh? So,
Many points kwenye hii safari ya
you said that one. Yeah, but 1, 2, 3. 1, 2, 3. Okay? Interconnected. So now let's start, eh? So we measure there and there. So which means there is continuity between that point and that point, eh? Again, ngatwasasisha twaleta hapa na hapa. So which means two windings are okay. Now we shift to there. Yours are even. Are we there? So which means all the windings are what? Are okay. The part winding, ground testing.